Welcome back. We're in Giancoli chapter 2, question number 1. Can an object have a northward velocity and a southward acceleration? Okay, well first let's establish that north is going to be up here as it usually is. And if I have some object, and we'll just put a dot there for the object there, and say that its velocity is going this way, let me just draw what the statement has said here. Can it be going that direction and have an acceleration that direction? Well, first, let's go back to what acceleration means. Acceleration is some sort of changing velocity over a change in time. Another way to think about this vectorially is to think about, hey, this acceleration vector that's right here, this tells you how the velocity is changing. So in this case here, the acceleration means that the velocity is changing in the green arrow's direction, right? Because over time here, this is telling us acceleration. Another way to write that is to get rid of that A and write it as a change in velocity per time. We know that time is always going to be running on there, so it is, but it's telling you which way the velocity is changing. So after some time here, if we have this line that represents some time that's passed here, if this scenario played out over some time here, that velocity, would it get bigger or smaller or stay the same if this was the acceleration for the green? You're correct. It would have to get smaller because it's changing in the southward direction. If I then let it go for even more time here, you could imagine that maybe the thing would stop and the velocity would be 0. And if I let it go for even more time here, and I guess on all of these, we're assuming that it's still accelerating this way, so let me draw that in there as well. Okay. And if it was still accelerating but the velocity was 0, we'd let it go for even more time. That again means that the change in velocity over some time here is going to be pointing downwards there, meaning that in the next instance here, the velocity then must be going that way. Notice that how in each case here, we have a velocity vector. Oh gosh, that jumped up. We have a velocity vector that is really big in the first one, and then it gets smaller. If I try to graph that, let me overlay the original velocity vector in a different color here. That's the original velocity, you might say, v naught. Well, now the change. Look at the change. The change is from this one. It was from this one here to this one. Ending minus beginning, final minus initial there. And this change, that is the change in velocity vector. Notice that the change in velocity vector is pointing in the same direction as the acceleration because acceleration is your change in velocity there. You probably stopped for a quick one to check it, and you found out there's a lot going on in this problem here. That's it. Hope you have a wonderful day. Take care. Bye.